So it's been about 5.5 years now that I've been making these custom 3D printed bases, and to date I think I've done very close to around 2,000 of these things. So I figured now is a good time to show everybody exactly how this process works, because there are a lot of people out there that are very interested in doing this on their own, and a lot of people that have tried doing it on their own. And well, nobody's gotten it quite right. So I thought, let me show you guys how I do it step by step. However, we're going to skip the first part of these steps because I already have tutorial videos for the first 2 steps in this process. And that was the mold making and the photography of the mold, right? Because that's how this has always worked for us. Customers don't send us their specimens. Instead, they make the molds at home, photograph it, and upload those photos to us. So that's where this tutorial video is going to start. It starts where the other videos that you can find on our website and on YouTube, starts where those end. Now, before we get totally into this, I do need to say that this process is a commitment. It's a commitment of space, time, and money. It's not a very simple thing to just pick up and do. And you're also going to have to learn several pieces of software, which can be a bit overwhelming at first. I'm going to go through step by step with each of these pieces of software and show you our method, but I'm not going to treat this video as a tutorial of how to use Blender and Metashape and all these other things, because that would be a 20-hour long video. So just know that there are 3 pieces of software that you will need, and you're going to need a pretty good computer to process with them. Now, I've got a 5-year-old Mac Pro, it's like an M1 Max Pro or something, totally decked out. It was the top of the line at the time, and it works fine. So you don't need the latest and greatest. Just have a good computer with a lot of GPU cores, because that's what's going to count. First piece of software is called Metashape. Metashape is photogrammetry software, and what that does is you just feed it a bunch of photographs of something, and it calculates what the 3D model should be based on those photos. Metashape is fantastic, and it comes in 2 versions. There's a Pro version, which you do not need, that costs over $1,000 last time I checked. There's a basic version, which when I bought it was only like $86, I think, something like that. It was very inexpensive, and it was a one-time purchase. It's not a subscription, so you put in your 86 or whatever dollars and you're done. I'm sure the price has gone up in the last 5 years, but it's not going to be a lot. The second piece of software that you're going to need is Blender. Blender is a very popular 3D modeling and animation program that has really gotten good over the years, and that is what we're going to use to do all the modeling of the 3D base. And third, you're going to need slicing software for your 3D printer. Now, there are several programs out there. You can really use whichever one that you're used to using, but the one that I use is Chitubox. It's just the one I use because it's the one I was brought up with on my 3D printers here. It's just the one I like to use, even though it's got its issues, as you're going to see when we get into it. So those are the 3 pieces of software you're going to need. And like I say, this is not going to be a tutorial for those 3 pieces of software. You're going to need to go on YouTube and learn how to use Metashape on your own. You're going to really need to learn how to use Blender on your own, and then learn how to use the slicer for your 3D printer. Tons of YouTube videos out there to do that. If I tried to put it all in this video, we'd be here for a week. So I'm just going to show you our techniques, what we do, and special tricks to the trade. Secondly, a whole lot of equipment is involved with doing this, and it's not just the 3D printers. So here I've got the 2 3D printers that we're currently using. They're both Elegoo printers. The big one is a Saturn printer, and the little one here is a Mars. I've been very happy with the Elegoo printers, and what's important to note about them is that these are resin printers. These are not the FDM printers where it just you have a spool of basically plastic twine and it melts it and it just oozes out a bunch of plastic to build stuff. I've seen people try to do that to make these sort of bases. It doesn't work. Just don't even go down that route. Those printers are not high enough resolution to get this kind of quality. You definitely will not be able to do the text on the front with an FDM printer, and you're not going to get anywhere near the accuracy that is required to make this museum quality. So you have to use a resin printer. And with the resin printer comes a whole lot of other stuff that you need, starting with gallons of 99% isopropyl alcohol. I mean, these are gallon jugs that go into the cleaning station, that go into these other cleaning stages right here. And because we're dealing with toxic resin IPA, we have to have a ton of personal protection equipment, a lot of PPE. And we're going to start with carbon filters. So, well, actually we start with this enclosure. So this is basically a grow tent, right? You get this on Amazon for basically $100. It's super cheap. But when it's printing, this thing is enclosed so that the fumes kind of stay in there. And then I've got a humongous carbon filter with a fan so that any fumes go through the fan and it clears that out. But then the room is also covered in carbon filters. I've got a Winix filter over here. I've got another Winix filter over there. I've got a Dyson over there. And then up in the ceiling, I've got a carbon filter in our return or our intake for the air conditioning so that it doesn't suck fumes out of this room and into the rest of the house. As you can see over there, I've also got respirators with various types of filters on them for the various things that we're going to be doing. You got to get the gloves. There's just a lot involved, okay? Just be prepared for that, and also be prepared for this whole thing basically taking over an entire room of your house. You don't want to do this in your bedroom. You don't want to be anywhere near this when it's going because of all the fumes going on in here. So there is a lot of equipment, and there's more equipment over there that I'll show you towards the end of the video, and some more equipment over here. This whole room is equipment required to do this. So like I say, big commitment, but I'm going to show you guys how it's done. And this is a long video, so bear with me, but let's go ahead and start. Okay, so our first step here is going to be to process all the JPEG images that we shot of our mold, process them in Metashape. Like I said before, this is not going to be a tutorial on how to use Metashape because we would be here all day. But what I want to show you is my workflow and how I go about doing this. So the first thing is that for the purpose of this demo, we're going to do two different mineral bases. We're going to do one that does not have a back support and one that does. And I've created two separate folders on my desktop for that. And I've put the JPEGs into a subfolder. So mineral A is going to be the one with no back support. Mineral B is the one with the back support. I've shot all the photos. I've put them in this JPEG folder, and here they are. Now, you don't have to name this folder JPEG. You can name it whatever you want. I just do that because it makes logical sense. You don't have to name it Mineral A and Mineral B. You just need to organize this, and this is the best way to organize it. Okay, so in our case here, we're going to do both of these. So I'm going to drag these over. I'm going to say, create a chunk from each subfolder. Remember, a chunk basically is just, it's a model, okay? We don't want to merge these. That would merge them. We want to create two separate models out of the two separate folders, so select that option. Click OK. It adds them. Now this default chunk we can just delete, so just say remove chunk because that's empty. And we've got our Mineral A and Mineral B. Let's just, I don't know, let's just, for clarity, let's say this is a fluorite, okay? Fluorite. So I'm going to name it fluorite. This is just how I usually work with it. Oops, calcite. Call that a calcite, okay? Now, there's a step that is optional, but it's only optional if you shot your photos with a really good camera like I did. So I shot these on my Sony RX100 Mark VII. I know that when I shoot these photos, they come out fantastic, okay? If they were shot on an iPhone or any mobile device, any low quality camera like that, you're going to need to do this next step, and here's what it is. Select any photo from either one of these, it doesn't matter, just right click on any photo and say estimate image quality. And you're going to say the entire workspace. We're going to do every single photo we've got here. And what it's doing is it starts scanning the photos. You'll see under the quality column here, it starts spitting out a number. And we want high numbers. The higher the number, the better Metashape thinks this photo is. Okay, so that didn't take long. So let's go to the first one here, fluorite. So you can see the lowest quality image here is this 0.6551. Generally speaking, you want all of your photos to be greater than 0.6. If anything comes in scanned at less than 0.6, I throw it out. That means that there's either something out of focus or there's motion blur or whatever. And this is quite common if you're shooting the photos on an iPhone. Okay, you're going to have much lower quality photos, and you will have some in here that may be 0.3, 0.5, 0.4, whatever, and you will generally not have this many in the 0.8s. They're going to be lower quality. So what I will do is I'll just delete any that are too low, but these are all okay. Now let's check the calcite. Now the calcite, you can see they're also all really good, except we've got this one that's a 0.279, and I know what this is. It's because I accidentally shot a picture of nothing. I accidentally fired off the camera and it just shot this blurry nothing photo, which is why it came out as a 0.29. We don't want that in our scan, so I'm going to either I can just disable it or I can just remove it completely. So I'm going to remove it. It's garbage. So that's what you're going to want to do if you know that you're dealing with low quality photos. But in my case, I skipped this step. Okay, the next thing that we're going to do is this. Okay, we want to switch our view back to small thumbnails. You could do large thumbnails too, but what we want to do is we want to find a photo that has kind of the widest shot that we've got. Okay, this one's pretty good because what we're going to do is we're going to create a mask. We don't want to create geometry for this little cloth pattern in the background. We don't want it scanning all this stuff and just wasting geometry. So what I do is I go to Intelligent Scissors and I just start selecting the stuff I want to mask out. So I want all of this to just not be scanned. Okay, and then we just click Add Mask to Selection. Boom. So now that'll be eliminated. Now, in this case, I might also want to pick a few others, like, oh, here's a shot where I don't need any of this other stuff back here. So I'm going to select everything below the centimeter line. This we don't need this. This is not part of our scan. Okay, and I'm just going to hit the same thing, eliminate that. And you can do this from multiple angles. Here's another one. I could do it here. I could just start eliminating all this stuff. And to speed things up, I'm not going to go through the whole thing. Sometimes what I will do is when I start shooting these photos, I will get really high up and just shoot one straight down that's a wide shot so that I can work with that. But anyway, we've created a mask for that one. Now let's create a mask for this one. Let's look for a nice, where's the widest? Yeah, we don't have a really good wide shot. Oh, no, that's not that great either. So since we don't have any good ones, we're gonna have to just go through several of these and start trimming. So I'm going to eliminate this garbage. Let's find another one. Well, yeah, this is a little bit of, here, you know what? We're gonna do this. We're just gonna start removing this stuff. Okay, and so on and so on. Like I say, I don't want to do too much of this because we'll be here all day, but oh, here's a good one. Here, we're gonna just clip that. That's kind of close, but let's see what happens. Okay, we're gonna eliminate all of this fabric stuff that we do not need scanned in. All right, you can do as much of this as you want, the more the merrier. All right, so now we need to actually process this. Now, assuming that you do know how Metashape works, you know that normally you would go to workflow and you would first align the photos, build the model, build the texture, so on and so on. You would do this by hand. I don't do this by hand because I do dozens or hundreds of these things, right? I've done almost 2,000 of these. So what I have done is I've created a batch, right? I set up my settings once. I saved this little batch file. I'm going to reload my batch settings in. And now I'm going to show you what I do. Okay, here's what my settings are, and here are all my steps. The first step is to align the photos. And a lot of these are the defaults, but I set the accuracy to high, and the important numbers are really going to be these three. The number of key points you want and the tie points and all that. I've messed with these. These are really the sweet spot. As a matter of fact, if you look at most of the YouTube videos for Metashape, you'll find that these tend to be kind of sweet spot numbers, but 40,000, 1,000, 4,000. Just set it to that. Trust me, those are the numbers you want. Okay, then This next step is a step that a lot of people skip. They don't even realize that they need to do it when they're manually processing this. This is the optimize. Actually, wait, hang on. Let me widen this. Oh, not widen this. How do I do this? Okay, widen this out. Optimize alignment. You don't need to change anything. Okay, just use the default settings, but you need to have this step in there. What it does is after you've aligned the photos, it basically tells the software to figure out defects in your camera lens, right? No lens is perfect. There's going to be some warping and some inconsistencies in the lens. And if you don't optimize it, basically correct for those errors, your model's still going to be really good, but it's going to be a little off. Some stuff might not be as accurate as it could be. So make sure you have optimized alignment in there. Okay, once you've done the optimized alignment, the next step is going to be build the model. Once again, I've left most of the defaults in here, but some of it has changed. Just make sure that your stuff looks like this. The one, well, there's a couple important things, but the most important thing to note right off is depth map quality. Say that 100 times in a row. Depth maps quality. If I'm shooting on my Sony camera where I know that the photos are really high quality and I know that every grain of sand is crystal clear, then I set it to ultra high quality. This takes a really, really long time to process though. Now, if somebody sends me a bunch of photos that they shot on their iPhone and they're just not very good, right? I mean, the numbers that came out in that quality rating are not the best, then there's no point in doing an ultra high quality scan. You're not going to get anything out of it. It's just going to take longer, and actually this can work against you. Okay, you can end up with a worse scan in ultra high quality mode on bad photos than you would in just regular, regular high quality mode, with mediocre photos. So for the sake of speed, because it takes way less time to process this in high quality. I mean, we're talking like, I don't know, 3 times faster, roughly, I'm gonna guess, maybe even more, to do it in high quality mode versus extra high quality. But if you've got good quality photos, do ultra high quality. Okay, just for the sake of speed, I'm gonna set it to high. And then the next thing you wanna set this to is face count. You wanna do a custom face count, and I have it set to 1.2 million. This is how many triangles are gonna be in our final model that it outputs. This is a bit of an arbitrary number because, I mean, if you're scanning an itty bitty little mold for a tiny little crystal, then 1.2 million is going to be way overkill. That is a lot of triangles, way more than you need. But if you're doing a really big mold, a really gigantic one, then 1.2 million might be on the low side. You could probably do with a little more. Okay, you might want to bump it up to 1.5 or so. But in my case, I just do 1.2 million for everything, and I just end up with extremely high resolution models for small stuff and kind of normal resolution for big stuff. But anyway, 1.2 million is what I like. The rest of this stuff, I think these are all the defaults, but just check with what you have. Make sure that it looks like this. And then after it's built the model, it's got to build the texture map, and you want to make sure it's at orthophoto for the mapping mode, and then the texture size can kind of be whatever you really need. For years, I used to do 8192, because that was a nice clean power of 2 computer-friendly texture size. But I found that sometimes the ruler, the little tick marks on the ruler could come out blurry in some cases. So I just upped it to 10,000. It gives me slightly clearer texture maps. You can bump that up to 15,000 if you want. You're gonna have a huge file, but you can do it. It's whatever size you think works. For me, 10,000 is a good number. The rest of these numbers or values, I think, are all defaults, but just double check. And then finally, when you export it, so as far as the path goes, this is in the Metashape documentation. You can read how to set the path. I have the path set to go to these folders, the Mineral A, Mineral B folders. I want to just save the file in there, and that's what this does. I'm going to save it as OBJ files. I want JPEG textures, and I'm pretty sure the rest of this is just whatever the defaults were. Okay. At this point, you're ready to go. All you have to do is hit the OK button, and it's going to start. Oh, I'm sorry. You have to tell it where you want to save. Now, this isn't where it's going to save the models. This is where it saves the Metashape work file. So I'm going to save it to the desktop. I just call it X, doesn't matter. I throw it away once I'm done. And you'll see as soon as it starts, here it created an x.files and an x.psx thing. These are just the work files for Metashape. When it's done, you can delete these. But it is going to save the models into the Mineral A and Mineral B folders respectively. Now we did high quality mode, so it's not going to take forever to do this, but as far as how long this can take, totally depends on how many photos it's processing and how many GPUs you have in your computer. Now I've got a MacBook Pro with an M1 Pro Max chip, which at the time was top of the line. By today's standards, it's probably a little bit slower. The M5 is the current thing, and it would probably beat the pants off of this. But what will happen, at least in my case, is, so I shoot really high quality photos with my Sony RX pocket camera. Therefore, I don't need so many photos in my scan. I usually shoot, 32, 33, 35, something in that range. If it's an iPhone, though, you need 50 or more photos because the photo quality is so much worse on mobile cameras. And I have people, sometimes they'll send me anywhere from 50 to 100 photos per base. If there's like 80 photos and you're doing, an ultra high quality scan, that could take, 30, 40 minutes to do each one. Now in high quality mode, it's going to be a lot less, but it's still going to take a while. In my case, I'm doing just regular high quality mode, 32, 33 images. This isn't going to take long. You can see right here, it's generating the depth map. That is the slowest part, and it's the part that we're going to sit here the longest for. This timer generally goes up before it starts going down. So since this is going to take a while, I'm going to go ahead and skip into the future. Okay, so I don't know, about 5 minutes has passed probably, and now we're in the generating model phase. So it's going ahead and it's building the actual geometry. And this is also going to take a few minutes, so I'm going to go ahead and skip again into the future. Okay, we're almost done with the building model phase after a few more minutes of waiting. And then, wait for it. Okay, so now we have the model back there, and as you can see, it's now working on the texture. And you can also see already the areas that we masked out. Some of the photos still had some bits of these areas in it, so it still scanned some of it, and we missed a whole area down here, but we masked out most of it. That's really what's important. Okay, so we're still building the textures, and this is building, by the way, remember, both of these at the same time. And you can see where it says 1 out of 2 is done, so it's working on the second one, and blending the textures. It's about to map it on there. There we go. And now it's saving both files, and it's saving them into both of these folders. Okay, so it is now done with the scan, and here is, oh, by the way, the mouse navigation in Metashape is terrible. But here you can see the second one, the calcite, and then if we want to see the fluorite, just double click up here, and then it loads that one, and here's the scan there. And you can see, once again, that when we masked it, it masked most of this garbage area out that we didn't need, but a little bit still made it in. Not a big deal. Okay, there is one thing that you want to check, especially, if you're doing this, you're new to this, okay? And that is to go up here, and these are all your display modes, how you want to see it. Default is textured. This is what we're looking at. You can do solid wireframe. You want to do confidence, okay? Confidence brings up a heat map showing how well your scan came out, how good it came out. Blue means fantastic. Red means terrible. So what you want is you want to see this. You want to see your mold blue. The little few speckles of green are perfectly fine. You also want the ruler, like I say, navigating in here is a pain, but you want your ruler to also be blue and or a mix of green. And let's check the calcite, see how that one came out. Okay, same deal. Looks really good. Yeah, there's a little, I didn't get as many photos of the back side of this as I normally would, and that's probably why it had a little bit of a problem underneath here. But still, green is fine. You don't want a lot of green, you want mostly blue, but a little bit of green is perfectly fine, and nothing important is red. That's what we want. Okay, the only thing red is just these outlier things. So if, for example, and this happens a lot when people shoot with their iPhones, or they shoot with really bad lighting actually, if there was a shadow inside of this impression, like say over here, and it couldn't scan this area because it's all black in the photos, you would see red here. You'd see red and yellow indicating this is bad. And if you see that, you just need to redo the photos and do this all over again. Make sure you have enough light. Make sure this whole thing is blue and or green. And basically that's it. We now have in our folders here our OBJ file with the MTL and the JPEG file. This is ready to be imported into Blender, and that will be our next step. Okay, so now we are in Blender where we're going to actually model our custom base. And I'm using Blender 5.2, so if you're watching this video far in the future, things might look a little different, but overall, the sequence of events here is going to be pretty much the same. And like I said before, I'm not trying to do a Blender tutorial here. I'm going to assume that you know how to use Blender. And if not, there are a million, and I literally mean a million Blender tutorials out there on Facebook. But I'm going to go through my workflow and how I actually go about this step by step. But before we get to that, we've got to talk about how we need to set up Blender first. So first of all, you need to configure Blender to be set up for 3D printing. Basically, you have to set it to millimeter mode and a few other settings that go along with that. It's kind of a process, and there are, once again, a million YouTube videos that you can look up to do that. Just go ahead to YouTube and look for how to configure Blender for 3D printing, and it'll show you how to set it up into this mode. And the mode that we're in here is such that each one of these big squares is a centimeter, and all these little squares are millimeters. And that's kind of critical because the scale here needs to match the scale of what we are actually printing. The second thing to note, which you might have noticed already, is that my default cube is different than the normal default cube in Blender. That's because I have replaced it. So you can actually replace a lot of defaults in Blender, like the millimeter mode for 3D printing. So every time I launch Blender, it's in the right mode, and it also loads this. The reason I replaced it is I put this wireframe rectangle in to represent the build volume of my Elegoo Saturn 3D printer. And I use this so that as I'm building the base, I can make sure it's not too big, right? If the base goes outside of the bounds, then I know that, oh, my 3D printer can't handle a base that large. So it's here for reference. The other thing to note, you're going to need several add-ons or little plugins activated. So go to the Edit menu, go to Preferences, and then go to Extensions. And you need to have these top three installed. Now, there's a million free add-ons in Blender, but these are the three that you have to have. The 3D Print Toolbox, this has tools for 3D printing related stuff. Bool Tool, this is, helps you with doing certain types of Boolean, or it improves the Boolean process. And Mesh Align Plus, which is one of the first things you're going to see. This just helps with something at the very beginning of building our model. So make sure you've got those turned on. And the other thing to note is that because I do this a lot, and I've built hundreds, actually almost 2,000 of these bases at this point, I also have a lot of quick favorites set up. So when I hit the Q key, it brings up my quick favorites, and these are just shortcuts to a lot of the tools that I use. Now, all of these are going to be up here in the, the mesh tools and vertex. All these are here, but it's so much easier to just hit the Q button and go to the favorites that I've set up. Okay, so the next thing about the pre-setup is that you don't want to be building a base completely from scratch every time. That would take forever. So what I've done is I have pre-built some parts, and I'm going to load in. I've got a little file. And let me hide the build volume there. These are a bunch of parts that I have pre-built. And the first four of them here you can see are bases. So let me just turn everything off but the first one. I'll show you one by one what I've got. This is basically a blank for a base. And this is the one that is 0.75 inches high with, it says heavy, and the heavy refers to the bevel. This is the normal bevel that's on 99% of our bases. Then this next one says thin bevel. You can see it's just a blank for a base with a thinner bevel. This is the one that I use when I'm making really, really small bases and I need a very narrow bevel. And then I've got a 1-inch base and a 1.25 inch base pre-built. Okay, so this is what I've got there. The next one is the locality label. So I have just pre-built just a text object, no big deal, with 3 lines of just gibberish text. It's in the font that I want. It's in the scale that I want. It just makes it easier than having to, create a new font object and set it up every time. I just have this, and then when I want, I can go in and, fluorite, blah, 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 Illinois. I can type whatever text, I want here to be on the front of my base. And then the last one, and this is the more complicated one, this is the infill for the bases. I have pre-built this, and you're going to see later how I use this. This is the only thing that's kind of complicated here, because our bases are technically hollow, but they need some structural support, so I'm using this honeycomb infill as a support thing. And your first thought might be, well, hey, my slicer for my 3D printer, it has an infill option. I can just have that. I can just have that generate the infill. No, no, no. You can't. It won't work right. It won't do what you want it to do. And you're going to see why later. But you need to pre-build this geometry. And this is much simpler than it looked. Somewhere up here, I forget. It's maybe under mesh. It was somewhere in here, and I forget exactly where it is. There's a honeycomb option where you can literally just tell it, build me a honeycomb grid of X by Y number of honeycombs. It generates that pretty much instantly, and then I went in and I Booleaned these holes. These holes go all the way through, as you can see. And these holes that I put in there serve 2 purposes. One, they eliminate some of the resin, so it kind of cuts down on the cost of all the resin used. But primarily, these are drain holes. So when the final base comes out of the 3D printer and it's got this honeycomb on the bottom of it, these drain holes all over the place just make it easier to get the resin out of there. And that is basically the setup that you need to do ahead of time to build the base. So the next step is going to be to actually build it. All right, I have relaunched Blender. We're just going to start from scratch here. The first thing we're going to do is just go over to the model that was generated by the scanner, and we're going to drag over our OBJ file that we just made. Import wavefront OBJ. Here's our model. It comes out tiny, so you have to click on it, right-click, set origin to the geometry, and then just scale it up. Just scale it up to whatever you're comfortable with. It doesn't matter. And then we go ahead and we can turn on the texture map. Now, as you can see, it imports at this crazy angle. It's all cockeyed here. And that's because when we ran this through Metashape, it doesn't know what up, down, right, and left is. It just kind of scanned it and put it in at this, it just generated it like this. And so we need to flatten this. We need to get this thing flat. And that is actually pretty easy. And no, we don't go in and just manually eyeball it and start rotating this thing around and trying to make it, flat. That would take forever. Instead, we use the Align tool that I mentioned before, the add-on that we installed. And we're going to do this one, Align Planes. The way it works is we're just going to define a plane on the top of here and align it to the top of our build volume cube. So our build volume cube now serves a second purpose. And the way we do that is super easy. We just have to define 3 points that we know are flat. So I'm going to go into the vertex mode, and I know that the edge of the Lego here is flat. So I'm going to just select here. Let's go to the very outer edge. Select a point on the outer back left, front left. This does not have to be exact, by the way. I could select a point up here. It doesn't matter. We just need to define basically this L pattern, up, down, right. And then we go here into the tool, and we click the Start Alignment button. Takes a second, it thinks about it. Okay, now we have to tell it what to align to. Well, we're going to do the same thing here. Select our build volume and select the same points, this L pattern, from the back left to the front left to the front right. And now when we click Align to Active, boom, it just magically aligns our model to that orientation. So if we look at it from the front, it's perfectly level. Look at it from the side, perfectly level. However, because of the rotation here is kind of determined on the points that we selected. So if we didn't do a good job of selecting a perfect right angle L, this will come out a little bit rotated out of whack. Now let's see, I just drag a, oh yeah, you can see, look, it's rotated clockwise just a fraction of a degree really. So I'm going to go in here, rotate it counterclockwise just a tiny bit, and then just drag this little selection thing. That looks pretty good. Here, let me try the bottom. Oh, it needs to rotate just a smidge more. Okay. Yeah, that's close enough. Okay, so now it's perfectly aligned. The next step is going to be to scale it, because like I say, we just scaled it up arbitrarily. We need to make sure it is the correct scale so that our base prints out not half the size we wanted it or 3 times larger than we wanted. It needs to be the exact size. And the first thing I like to do is to get rid of some of this unnecessary geometry to make our lives easier. So I go into edit mode, I just go into face mode, and first I'm going to select this because I know that we need this. We need the actual impression, and I'm going to select the top of the ruler because I know that we need the centimeters. And then I'm going to do Command-I to invert it, then hit X, and just delete, it doesn't matter, vertices, just delete anything you want, vertices. It deleted them, and here we go. So now we've just cleaned it up, it's easier to work with. So we have tick marks on our ruler. The way that we scale this, and we also have centimeter marks and millimeter marks, we need to align these centimeter marks with the centimeter grid in Blender. Pretty easy to do. And the way I do it is I'm first going to set the cursor, the Blender cursor, to one of these centimeter tick marks. And I always start with the cleanest one. So you can see that it's a little messy on the edges. As a matter of fact, if you go to the right side, yeah, it's really messy over here. So we don't count those. What we want to do is I start on the left and I look for the first one that's really clean. This one looks pretty clean, but these next few, I don't quite trust them. So the 5 here, the 5 centimeter mark looks really clean. So let's center it, right click and say set origin to the 3D cursor. Okay. Now make sure snapping is turned on, and then we're going to snap to grid. Okay. And all we got to do is just hit the G button and drag it, and now you see we are snapping over there. Okay. Alrighty. Now it looks like we did, oh, we're almost close here. We need to scale this. We need to scale it so that the tick marks on the ruler match the grid. So just hit S and start scaling away. Go over to the right. I don't know what, I'm getting some weird Blender artifacts at the bottom here, I think. I just downloaded the new version of Blender and I think it's got a little display bug here. So if you see little dancing cubes at the bottom, it's just a Blender glitch. And okay, we don't care about the stuff on the edge because it's not reliable. It's clearly a little warped. So let's just go to the 23. That looks like the last really clean one. And as long as everything lines up, which it is, then we know that our scale is perfect because our ruler matches the grid perfectly. So let's go ahead and trim this down a little more. And now really, let's take a look at this. You know, these are the lines that we did in the sand which demark the edges of our base. So we're just going to trim to right outside that. Let me just select outside. And I know it's very hard to see what you're doing because this mesh is so dense it just looks black, but you'll get used to it. Select what you want, Command-I to invert, hit X, and once again just delete vertices. And now we're down to this. Okay, we've cleaned it up. So let's go ahead and move this, just center it a bit just so we can work with it a little better. The next thing we need to do, oh, well, actually, let's save. I always like to save as I go along because, well, You never know if Blender is going to crash. It usually doesn't. It's very stable, but every once in a while it crashes. You don't want to lose your work. Okay, first things first. This is our build volume, remember? And look, our base fits inside of it. So we know my Elegoo Saturn printer can print this. Okay, that means we don't need this anymore. We can go ahead and hide that build volume. The other thing to note, and this is a very, very important step, is that when Metashape creates this mesh, there are going to be artifacts, little stray polygons and vertices here and there that it's just noise. There's not a lot of it, and sometimes it is really hard to see it. Like, I don't see any of it this time. Okay, it looks perfect, but I'm willing to bet it isn't perfect. And how do we find these little artifacts? Well, it's easy. You just select the mesh, go over to edit mode, select everything. I'm going to go to my quick favorites. I'm going to say separate by loose parts. Now, you could also do this, I think it's from the edit menu or wherever this option is, but by loose parts, and boom. Now you see all these dots here. You also see in our object list a ton of these. Every one of these is an artifact that got left over, that it was just an error in the scan or an artifact of the scan. It's just probably so tiny that we couldn't see it until we did this. So how do we delete them? Well, it's pretty easy. Just select what we want, which is this main mesh. Select Command-I again to invert the selection. That will select all the stuff. Hit X and then delete. Boom. And that deletes all of the artifacts. I'm going to save again just in case something bad happens. Okay, next step is to start building the actual base. So I'm going to load in those pre-made parts again that I showed you before. And I'm going to make this a 1-inch thick base. So I'm going to go ahead and just turn off all these other ones. I'm going to turn off every other layer. I don't need this other, just the base. And then I'm going to go to side view, and I'm just going to drag this to be below the base. Also, it helps to turn snapping off at this point. Okay, then I'm going to go back to top view. Now you can see that our stock pre-built base does not match the lines in the sand. So we just need to resize it. The way you do this, you have to start in wireframe mode, otherwise bad things will happen. Oops, sorry. What did I just do? There we go. And we're going to select these vertices. I'm going to go back to shaded mode now that they're selected. And I'm just going to drag it over until it's on the line in the sand. Then I'm going to go to the right, select these vertices. And you have to do it in wireframe mode. If you try to select the vertices in shaded mode, it will not select the ones at the bottom. It'll just select the visible ones at the top, and then it breaks it. So you have to do it in wireframe mode. Select the top ones, hit G, Y, drag them up. Wireframe mode, select bottom ones, G, Y. There we go. Okay? So now our base is the correct size, and we can go ahead and hide it for now. Matter of fact, I'm going to delete these other ones just because we don't need them anymore. And once again, we're going to trim this down. I like to go into shaded mode so I can see what I'm doing. And we're just going to eliminate a little more geometry. We know we only need the indentation, right? So I'm just going to start selecting what I do need. It doesn't have to be exact. Just, whoops, oh, sorry. I didn't have it. I was in the wrong mode. I'm sorry. Let's do that again. Okay, selecting what we do need. Okay, and once again, Command-I, invert it, hit X, delete, and faces, vertices, doesn't matter. Oh, it did it again. All right, well, this is a different remaining artifact. So you can see more artifacts here. So let's go ahead and delete them. Just go back into the editor, select all, loose parts, it separated them all out again. Select our main object, Command-I, invert, X, delete. Boom, we deleted all the artifacts. So the reason you have to be really careful about deleting all those artifacts is if you don't, those artifacts will be in the final model and they'll be in every stage of building it, and it will cause errors to occur along the way. And some of those errors will be unrecoverable. So you will get to a point where you won't be able to do certain Boolean operations on the mesh anymore. It'll fail. So you have to be very careful that you do not have any artifacts. This needs to be one mesh with no stray polygons or vertices hanging out. All right, so we're good. So now let's put our base back up again, go to side view, and now we're going to align our impression with the base, line it up how we want it, okay? And we need to make sure, check both sides, make sure it doesn't go over the edges. We're pretty close. Now, if it did, let's just say, for example, it did go over the edge. It's pretty easy to fix. Just select the base, select this, and just move it further away, right, if you need more space. So let's just give it a couple, 2 millimeters extra room just so the thing doesn't go right up to the edge. But other than that, this looks good, okay? Now we got to Boolean it. So we're going to select the impression, then shift-click the base, and then Control minus key. And that does the Boolean. So if you go down here to our modifiers, you'll see it created the Boolean for us. There are 3 types of Booleans that Blender has built in. The best one, and the one that you want to use whenever you can, is manifold. But that only works when you're Booleaning 2 manifold objects, and we are not in this case. The base was manifold, but this impression geometry that we had is not. It's not an enclosed thing. So you can only use float or exact. These tend to generate errors or even fail. Like let's see. Yeah, okay, see, look at that. I tried exact and it failed. It's doing something just crazy here. So in this case, we have to use float. All right, and we're going to Command A to apply it. We're good. Now we can just delete the old Boolean geometry thing there, and here we go. Here is our base with the impression in it. Pretty cool. Okay, now, like I said, the Boolean tool is not perfect in Blender. The manifold Boolean tool rarely ever fails, but the other 2 do. So to make sure that there are no errors, we need to go to the 3D print tool. Okay, select it and click check all. And that's going to take a few seconds. It's going through 1 point whatever million polygons, or not quite. We've deleted a lot of them. And there's 2 things we're looking for here, the top 2. Non-manifold edges, this has to be 0. If this is not 0, errors are going to occur further down the line. Bad things will happen, and like I said, sometimes they'll add up and become unrecoverable, and you'll have to start over from scratch. Bad contiguous edges, not as terminal. You want to get rid of them, but it's not the end of the world if you get stuck with a few. Getting rid of it's easy. You just click down here, clean up, click the Make Manifold button, and then just check it again, see what happened. Takes a few seconds thinking about it. There we go, zeroed, okay? It's perfect. No manifold edges, no bad contiguous edges, and don't worry about these other things. It doesn't really matter. All right, and we're going to have to do this. We should do this at several places along the line to make sure that the next steps don't introduce any additional errors. All right, so what do we have at this point? We have a solid base. This, if we printed this as is, it would come out a solid block of resin, and you do not want that. Multiple reasons why you don't want that. For one, resin is very expensive, and printing a solid block of it is going to cost a lot of money. Secondly, you really can't print a large solid object like this solid because you can never fully cure the resin on the inside, right? You can only really cure the outer millimeter or 2 of it, well, maybe a little more depending on the resin you're using. So what will happen is, it might look perfect out of the printer, but an hour or a day later, you'll see that your entire model is bulging because the inside resin is expanding. It doesn't work. You have to do these hollow. So how do we hollow this? Well, really easy. Once again, in the 3D print tools, we now go down to Edit. And we're just going to click on Hollow. And what I have found is that the magic offset, this would be the thickness of the walls of the base, is 1.75 millimeters. Oops, not 1 divided by 7.5, 1.75 millimeters. And I click OK. And now look at it in wireframe, and here you go. This is what it did. it created this inner wall, and it's a mess, right? It just creates this totally unoptimized geometry, and we want to clean that up. We can't really work with this, but first let's apply the hollow. So this is now an actual hollow model. It's got an air pocket. This whole thing's an air pocket in the middle. But let's clean it up. So first let's go in, select all, and say buy loose parts again. We use this a lot. And what that does is it separates the outer shell from the inner shell of our hollow thing. We want to clean up the inner one. It's a mess. So we go add modifier, generate, decimate. That's how we're going to clean it up. And we say planar, and I do either 2 or 3 degrees, but let's do 2 degrees today. And then apply. All right, and now you can see it cleaned it up. So let's just join the outer shell and the inner shell back together. So select both of them, Control J to join. And here is our object. It's completely hollow. Now we can't print it like this either, because if we print it like this with an air pocket in the middle, it will crack or explode. You have to either create vent holes or just open it up. And what we're going to do is open it up. We're going to cut a hole in the bottom so that it does not have a giant cavity in the middle. And this is pretty easy too. So what I'm going to do is I'm going to create a punch out slug, right? Using this tool just to create a cube on the base. I'm going to go to the top view. And what we're going to do is we want to try to get this slug to go as close to the edge as we can. So I'm just going to move it around. I'm scaling it. I'm just trying to get it really, there we go. So that's close enough, okay? Now, we just need to move it up so that it's inside of the base. And then we just, we select the bottom one, the slug, the punch out, shift click the object we're going to punch out, and then once again, Control minus key. Boom, and there we go. It created a Boolean object and it cut it out. Now remember, we've got these 3 Boolean options. Both of these objects were manifold. We should use the manifold tool to minimize the odds of an error happening. I'm going to do Command A to apply. I'm going to delete the slug. Boom, and here we go. Now once again, it would be smart to do the check again. Just make sure no errors every time you do a Boolean, there's a chance of an error coming in. Like I said, with the manifold Boolean, the odds are pretty low, but still, it's always wise to check. Okay, this is basically our base, except that it has no internal support, right? This is going to be kind of flimsy with these thin walls, and if you put a heavy mineral on it, it might bend a little bit because there's just nothing holding it up. So this is where the honeycomb infill comes into play. The way this works is, now this honeycomb infill is this big thing. We need just an infill that is perfectly form-fitted to the interior of this base. It has to form-fit not just the sides, but this complex geometry of the impression. How do we do that? Well, it ends up it's really easy. The way we do this is basically like a cookie cutter. Think of the honeycomb is your dough and the base is the cookie cutter. So first thing we're going to do, select the honeycomb, and we want to just use the shift key to go really fine. We want to get it as close to the bottom as we can, but remember the base is the cookie cutter, so it's got to go all the way through. So we don't want you don't want it down here because then the cookie cutter is not cutting all the way through. You want it just to the edge so that the cookie cutter is going all the way through it. Then we're going to take a look and we're going to just kind of line it up so that there's no weirdness going on. Like sometimes when there's a gap like right here, that can be less than ideal. So I just kind of move things around a little just so there's nothing weird. Just give everything a little bit of space along the edges so it looks good. And then on the top, because we did a 1-inch base and this honeycomb was actually originally built for 3/4-inch base, we need to scale it up. So I hit SZ and I'm just going to scale it up so that it's just above. We don't want it to be under. It's got to be, it can be way up here too, but don't do that. Just make it a little bit above. All right. So now we need to perform the cookie cutter action. This is pretty easy. And this will work 9 times out of 10. But every once in a while, this is where the Boolean operation fails. So we're going to go add modifier, generate Boolean. We're going to do manifold because it's got the best chance of success. I'm going to use the eyedropper to select the base because we're going to Boolean the honeycomb, the cookie dough against the cookie cutter. Boom. Okay, let's apply this, and this is where we keep our fingers crossed. So hopefully the base cut through this. Let's make sure that the honeycomb is selected, select all. Once again, the loose parts thing, okay? And actually, I'm gonna hide that. All right, it looks like it worked. We now have an inside part of the honey. It looks like it's separated the dough. We have the outer dough. If I select it, do delete, boom, it deletes all the cookie dough that was cut out. And it leaves just the part in the middle. And as you can see, this geometry is perfectly formed to everything. It's not poking through. Nothing's poking through the top. It is a perfectly formed thing. As a matter of fact, if we turn off the base, you can see what it looks like, right? Creates this perfect thing. And that's all there is to it. So now we have a finished base. This is the base, but it's missing the locality label. So we turn that layer back on. And the first thing that we need to do is we need to center this. There's a few ways of doing this in Blender, but luckily they added a new feature. I think it was in 5.0 or maybe one of the late 4 something versions. To make this a little bit easier, make sure snapping is turned on. You want to snap to the center of the face. And then we just select this, grab until it snaps. Oops, why is it not snapping? Come on, snap. Why are we not? Do I have everything right? Center. Oh, wait, you know what? Do face center. Sorry. Face center. Snap. Oh, why are you not working today? Hey, sometimes it's finicky. There we go. You have to do it from a... That's because of where the origin is. Okay, there we go. Did it work? Yay, it worked. Okay, it's centered. But it's also not really where we want it right now while we're working. First of all, it's embedded in there. It's not sitting on the surface. It's embedded. That's wrong. Let's just move it out. I'm going to do GY. Just drag it out in front so we can work with this. And then we can edit it. So let's say this is going to be, whoops, fluorite on quartz. Let's say that's what it is. And let's say it's from, oh, I don't know, Elmwood Mine. I don't know. Okay, let's just do a simple label like that. Now, if I wanted to, of course, I could go into the font tool here, change which font I'm using. I can change the spacing, and there's all sorts of things you can do to customize this. But for now, this is what we're going to do. So the next step is we need to convert our text object to a geometry, to a mesh. So right-click, convert to mesh. Boom. Now, Blender has a weird thing about meshes when it does this conversion from a font to a mesh. I haven't checked to see if the latest version of Blender finally fixes this or not. We're actually going to find out now. Pardon me. It will generate some double-sided faces, which are not really what you want. The easiest way to clean this up is just select it, go into the editor mode, select all, and do merge by distance. And then make sure it's a tiny number. I have it set to 0.0001. It's teeny. But what that'll do is it'll remove any duplicate vertices and kind of clean it up. All right, so now we have clean geometry. We just need to snap this to the front of our base. You could eyeball it. You could just drag it over, but don't do that. You don't want to do that. We want a clean fit. So we're going to use another snap tool to do that. Go into face mode and select any face on the back of this text. And I mean any face. It can be this one, this one, this one, doesn't matter. And then swing around, and we're going to go closest face. That's what I was going to do before. Go into object mode, and just while your cursor is on the face you want to snap to, hit G, and that snaps it, but we want to just keep it aligned, so hit Y to keep it snapping only on the Y-axis, and that's it. Click. It's now on there. If we look at this from the side, you can see It is perfectly aligned. So technically speaking, we're done, right? This is our base. It's perfect. It's ready to go. Well, maybe, maybe not. And it depends on what slicer you are using. I'm using Chitubox, and Chitubox has a problem where this will not print correctly because it has planar faces, coplanar faces. Chitubox does not like coplanar faces. It will freak out. What is a coplanar face? A coplanar face is when two pieces of geometry have polygons on the same exact plane. For example, all of this text, the back side of this text is all exactly on the same plane as the front of the base. These are all coplanar faces on the back. Additionally, when we Boolean this out, everywhere that it touches the base, that's creating coplanar faces. There's hundreds, if not thousands of them. This is a problem, but it's easy to fix. Matter of fact, it's super easy to fix, and this is how we're going to fix it for the text. We're just going to grab it, we're going to go G, Y, and I'm going to manually type in 0.01, return. What that did is it just moved our text that way into the base by 1/100th of a millimeter. So if we look at it from the side again, we can now see it's just ever so slightly embedded into the base. These back faces are no longer coplanar with this face. This fixes the problem with Chitubox. But now we have to fix this. This is a little more complicated. How in the world do we fix this? Well, it's actually pretty easy. Just select it. Once again, go here, say shrink and fatten, and then type in 0.02. And what this does is it basically expanded all of these faces over here into the base. So once again, no more coplanar faces, problem solved. So now we have our final object. We are done. We're going to select it. Whoops, go in object mode, select the whole thing. In my case, I'm doing the shortcut to export as an STL, or you can go to the file menu and export as an XTL from there. Usually I do selection only just to make sure it doesn't accidentally export any other layers that I had turned on, and just say export STL. We go look over here. Here's the file. Let's just see what it looks like in the Finder. Yeah, there it is. A little hard to see, but there's our final model. And technically we would now go into our slicer tool like Chitubox and set this up for 3D printing. But before we do that, we're going to go through this whole process in Blender again. And the reason why, I know you're thinking, why are we doing this all over again? That just took like 20 minutes. The reason why is there is a slightly different process if your base has a back support. This one does not. So we're going to do this again with the other model that I have over here. Mineral B. This one has a back support. Okay, we're back in Blender here, and we're going to go at full speed and do this next one with the back support. Import OBJ file. Right-click, set origin, geometry, scale it up, turn on the texture maps. Go ahead and make our little L selection again with the back left corner. Oops, back left, there we go. Front left and front right. And then we say align, planes, start alignment. Okay, then we're going to go up to the thing we want to align it to. Same deal. 1, 2, 3. Align to active. There it is. Go to the top, make sure the rotation looks reasonably correct. It looks a little out of whack already, but let's see. Yeah, it needs to go counterclockwise just a teeny amount. So let's just, oops, oh, sorry, that's my bad. Rotate just a smidge here. That looks good. It's close enough for me. Okay, now we're going to go ahead and save this just so if something bad happens. And then we're going to trim it down. go ahead and select the inside part here and our tick marks on the ruler. Maybe a little bit more. Okay, Command-I, invert, delete. All right, now we've got our stuff that we need to work with the scaling. Let's find the first good tick mark. These are all pretty clean, but 6 looks the cleanest. So let's start with 6, put our origin there, set origin to the 3D cursor, snap to grid, zoom out, drag, snap it to the origin, and then we just get to scale it so that the tick marks line up with the grid. Go over here. It's pretty close. Yeah, I'm going to say that's good. Okay, we've got it scaled properly. Let's go and trim this down even more. Invert, delete. Okay, let's move this to the middle so we can work with it. And it does fit inside our 3D printer, so we don't need that anymore. Now we need to look for those artifacts, the scanning. So we're going to do by loose parts. And it looks like this time, we don't have that many this time. Very few scanning artifacts. We'll select what we want, invert, X, delete. Okay, now we have a clean model. Go ahead, append our pre-made parts. I'm going to do this also as a 1-inch base, so I will turn off all the other things, select the base, go to the front. Let's make sure that this thing is below the base so that we can work with it. Turn off the snapping. Whoops. And select the base. Let's do the left side first. Line that up. Go to the right side. Now sometimes you get this situation where the line in the sand is not exactly at a right angle, it's at an angle. So just kind of eyeball it. This is not an exact science. You can be off by a little bit and nobody will ever notice. All right, let's line that up. Line this up. All right, we're good. We've got the base the right size. Let's hide it. Now we're going to trim this down even more. I like to go into this shading mode so I can see. And wireframe mode, select the impression and the back support. Command-I, invert, delete. All right, so at this point, this is what we've got. We've got the impression and the back support. We can't do this exactly the way we did it before with the base. We can't just drag this up and do a Boolean subtract because the impression gets subtracted like we did before, but the back support is going to be a Boolean addition. And we can't do that on one thing. We have to separate these. So what we're going to do is make a copy. So I believe it's, yes, Control-D to make a copy of that, hide one of them. And on this one, we're going to go ahead and just remove, whoops, well, remove a little more than that. Come on. Just remove the back support. And then, there was something I didn't do last time, but it didn't work. You have to flip the normals, and I'm surprised it worked on the last one that we did, unless they've changed something in Blender where it accounts for this. But normally you have to flip the normals on this before we do the Boolean. I'm going to look into that later and see why that worked before. It should have failed. But anyway, you have to invert it. Let's go to the next one. On this one, we're going to do this. And now we have just the back support. But here's a problem. So the back support is really this, it's the support plus this base area down here that we need to get rid of. So the way we get rid of this is select the whole thing, go into vertex mode, and down here you're going to select the bisect tool. And what we're going to do is we're just going to trim off the bottom part of this. So go as low as you can, hit the control key to keep it level, and do that, go to bisect and just say fill the bottom. This will put a cap on the bottom where it's trimming it, clear enter to clear that out. And then we're going to go GZ. We're just going to bring this down so that we have a little margin to work with. You'll see why in a second. Okay, now let's turn on both of these again. Let's go to this thing, move it down into position, about where we want it. That looks good to me. And this is why we needed that margin, right? Because we trimmed it up here, our base wasn't going to, our back support was not going to intersect the base unless we kind of dragged down those bottom vertices into it. Also, you'll notice that in this case, our back support is going over the edge. Now we could do another trim. We could just trim the back side of this support off, but you might not want to do that. The easier thing is really just to, oops, I'm in the wrong mode, selection mode. Select these vertices and just move it back. There you go, that's good enough. Okay, now at this point, this pretty much goes the way we did it before. Select the impression, shift click the base, do Control negative, and it creates the indentation. Apply, and you have to be careful at this point because this is where Blender's Boolean function tends to create errors. It's when you do multiple Booleans on an object. I'm going to go ahead with this one. We're going to add it in and hope for the best. So select it, shift click the base, and this time Control plus to do an additive Boolean. And let's just take a look. I don't see any errors yet, so it looks okay. We're going to do, this is technically a manifold object, both of these, so let's apply them. Delete, and then we're going to go over to the 3D print tool again, check all, and hope there are no errors. Yay! Look at that. No bad contiguous edges, no non-manifold edges. We don't need to do anything. This came out perfect. It doesn't always come out perfect. Hollow it, 1.75 millimeters. Apply. There it is. Let's go ahead and detach the center. Generate, decimate, planar, 2 degrees or 3 degrees, whatever works. Okay, that simplified the geometry. Control J, rejoin them. We've now got our hollow object, but we need to punch out the bottom. So, whoops. Let's go ahead and create our little rectangle on the bottom. Go to the top. We're going to try to get this thing as close to the edges as we can. There we go. Oh, actually the Y, oops. Oops, my bad. That looks pretty good. Okay, go ahead, bring it up into the thing. Select it, shift click the other one, Control negative. It cuts it out. It's manifold, so select manifold. Apply it. Do that. Once again, good idea to check all. Make sure that the Boolean did not create any errors. I don't think it will yet. It looks clean. This new version of Blender looks like it's working a little better than average. Honeycomb infill. Let's bring it down. Whoops. Whoop, my bad. Oh, geez. Sorry, let me do that again. All right, remember we want to get this as close to the bottom as we can without going too far because the cookie cutter has to go all the way through. Then we're going to check, just check to make sure that the alignment's good. So I like to avoid having small little pockets like this on the right, and we've got big pockets here, little pockets on the right. So I'm just gonna, whoops. Oh, come on, what's going on here? There we go, move it over. Just kind of equalize things. I also don't like this. So let's, hang on, I'm having a problem with my axes got flipped around. There we go. Actually, that's good enough, okay. I mean, it doesn't really matter. I just want it to look symmetrical. All right, up here, we need to scale this quite a bit because we have back support. We can't just scale it so that it goes to the very top of the main base. It's got to go up all the way. It's got to cover the back support. So we get the whole thing in there. All right, now we're ready to do the cookie cutter operation. So add a modifier. We'll go to Boolean, manifold, and then we're going to Boolean the honeycomb with the base. Bada boom. Apply it. Select all loose parts to separate it, and yay. Okay, it's separated it out. Now in this case, you're going to notice we have 2 honeycomb infill pieces here. This happens a lot. This is not actually an error or anything. This isn't even an artifact. It's just a byproduct of sometimes the way the geometry intersects. You're going to end up with a piece that is not connected to the rest of it. You can either just select all this and then join them together, which is probably the correct thing to do, but honestly, I just delete the extras. It doesn't matter. I just delete any of these extras. You don't want little bits floating around, but either join them or delete them, doesn't matter. All right, so here is that. Now we've got to put our locality label on the front. I'm going to show you a different way to center it this time, just because there are two different ways. This is the older way. You're going to snap, you're going to go vertex, center, and this time grab and move your cursor over the front top left corner and see it snaps to there. You can hit A to set an anchor point, then go to the bottom right, click, and you'll see it magically centers it. So that's the other way to center it. Let's go ahead and move the text out in front. Let's go ahead and name it, I don't know, calcite from, I don't know, how about the La Viesca mine in Asturias, Spain. Let's do that. Okay, now we need to convert this into a mesh, convert to mesh. And like I say, I don't know if they fix this. Let's take a look here. It says that we have, wait, what do we have here? It says there are 77,000 faces, 56,000 vertices. They may have fixed this bug in this new version, but just for grins, let's do merge by distance and see what happens. Oh, I think the vertices went down. Okay, yeah, that still cleaned it up a little bit. So anyway, it's better than it was. Okay, so there we go. We've now got clean text. We're going to go over here to face, select any face. We're going to go back up here, closest face. Oops, what happened there? Oh, no, that was correct. Okay, GY, we're going to make sure we snap it to the Y-axis so it doesn't lose its centering, and then click. And now we've got a perfectly good base, except that we have to break the perfect geometry here for Chitubox. So we will go GY 0.01 to make the text go into the base just a teeny bit to break those coplanar faces. Then we're going to select this, select, shrink fatten 0.02. And now we are done. Okay, so now that is how you create the back support on a base. As you can see, it's essentially the exact same procedure as before. The only difference was that you have to kind of break up that scanned piece of geometry into two pieces, do a Boolean subtract here and a Boolean add on this. And at this point, we are ready to go ahead into our slicer and set this thing up for 3D printing. All right, we are now in Chitubox. First thing I need to point out here is I am running an older version of Chitubox. This is 2.3. They, I don't know what it was, about a year or so ago, came out with a whole new version of this, which people hated. Also, they did some stuff to cripple it so that they force you to pay a subscription for some of the features that you need. So I'm still using the old version. The only problem with the old version is that it crashes like crazy when we are putting the supports down. So this is something we have to deal with. But anyway, just so you know that if you download the latest version of Chitubox, it's not going to look like this. But the procedure is the same. So we're going to go over here. We're going to drag our STL file that we created in Blender into here. And the first thing that we need to do is we need to put some drain holes through the top. And the reason is, remember, this is going to be printed upside down. And if you know anything about 3D printing, you know that this causes cupping. There will be kind of a vacuum as this is lifted out of the resin puddle. And that vacuum causes the print to warp. It causes all sorts of problems. So we need to go to the dig hole tool. And we just need to go underneath, and what I like to do is just kind of find a few. This is a weird one, okay, because it's like a, lunar landscape. Sometimes you'll have an impression which clearly has a low point. It's more of just like a true indentation. You always want to pick the deepest part, but in our case, it is what it is. So dig hole, I set it to a diameter of 2, and just punch a couple of holes in what appear to be the deepest places. And sometimes it has to think about it for a second. Okay, in this particular one, I don't think I need that many holes, but I'm just going to put a couple more just to be safe. You don't want to riddle this thing with holes. You really don't need that many. Just put it in places where you think you will prevent any suction cups from forming. Now also keep in mind that we're not going to be printing this flat like this. Matter of fact, we have to rotate this. You cannot print a rectangular object flat. It's fast, it'll print really fast like this, but it will be mangled. So here's what I have learned over years. Set the X to -5 and then go Y either positive or -9 or 10. Okay, I will do 10 if it's it depends, it adds a little bit of print time, but because it's going to rotate it more. So it's just going to add, another minute or two to the print time the more you rotate it. But the more you rotate this, the better off you are. But 9 to 10 is the sweet spot. So just the fact that it's rotated is going to prevent most of the cupping, the suction cupping from happening on the top. So that's why we don't need drain holes on every single bubble here, okay? The next thing we're gonna do, well, there's a couple next things. It's gonna crash a lot. Let's go ahead and save our progress. So let's go into Mineral A here, just save that. And then we get to go into the supports. So this is going to vary based on your printer, your resin, and your slicer, but I just wanna show you the settings that I have for Chitubox for everything I'm doing. Okay, just take a look, make sure that if you're doing the exact same setup I have with the Elegoo standard resin and a Elegoo printer and just using this software, use these settings. This has taken me years of fine tuning to get kind of perfect. Right, that's what it is for the light supports. We go to the middle supports, slightly different settings here. But just make sure that these look like what you're seeing, and same with heavy. Just make sure all these numbers kind of line up. Okay, we don't need a raft. Sometimes people print with rafts, it's not necessary, but we're gonna go to auto support mode, platform, and click the auto support button to just have it give us a starting point. Now, this is wrong, okay? You can't just print with the auto supports because for starters, it loves to put supports that are going over the edge here. When you print this and then you try removing these supports, it's gonna put divots all over the edge of your final base. Anything that's too close to the edge causes problems. Also, it usually doesn't have enough supports in these areas, in the red areas. We need to add supports there. So what I do is I go ahead and I just remove the ones that are bad. All of these along the edge are bad. So delete, 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 delete. Just select everything along the edge that is not one that we want. Now you might be thinking, why did I even do auto support if I'm just going to be deleting all of it? Well, trust me, this is faster than doing it all by hand. Okay, these are also all along the edge. We're just going to delete the edges. Do. By the way, Chitubox never crashes when I'm deleting these things. It only crashes when I'm adding. All right, now this isn't as bad. All right, this one's too close, delete. This one's too close. This one's too close. These two are too close. Just delete anything that is going to cause a divot in the model when you remove the thing. Okay, we're good. Now, what we're going to do is we're going to make sure we have heavy support selected. Go back to our add, and we need to really reinforce the corners. If you don't reinforce the corners, they will tend to lift off during the 3D printing. Okay, so here's what I do. I'm going to add a heavy support to the corner. Don't get too close, but add one there. Add another one here. Another one in this corner. And then another one in this corner. Don't get too close. And then I'm going to go to the middle ones and I'm going to reinforce it even more. Put another one there. Another one here. Maybe another one here. And then I'm going to add just some of these middle supports, just more density in the corners, and then kind of just on the inner edge, I just kind of space them out like this. Let's add another one here to be safe, okay? This one looks okay. That one, it's got plenty of them there, okay? And we need to add a whole bunch more medium, middle supports there. Let's add one there, one there. Okay, that should be good enough. Now go ahead and save, because here's where it's likely to crash on us. We're going to save over the existing file, replace. Okay, let's see how far we get before it crashes. Save and save often, that is my motto. The rest of it we're going to do all light supports. Okay, just start clicking across, and remember, don't get too close to the edge. Okay, I just kind of go like this. You can go close to the inside edge because no one's going to see those divots, but on the outer edge, which is visible, be real careful. Okay, and don't crash, please don't crash. All right, we're almost. Yeah, sometimes it gets a little messy. All right. And also look for areas along here that, like, there should have been one there. That was missing one. It probably needed one. Anywhere else? Oh yeah, right here. It could use one there. The rest looks good. What I do is I save after each edge. So I did a full edge. I'm going to save because it's going to crash eventually. Let's go over and do the next edge. Okay. Whoops. And at this point, I'm just going to speed this up because I think you get the idea. All right, for some reason it looks like, I don't know, I thought I put a middle support right here in the corner. I missed one, so let's make sure we add that in before we finish this edge. And we did another edge without it crashing. Make sure that these little areas here, we're going to go ahead and save yet again. It's a miracle we've made it this far without a crash. And then I'll speed things up again. All right, we got another edge done. That's 3 out of 4. We are tempting fate here. And Chitubox crashed. Okay, that was inevitable. All right, and we're going to have to just relaunch it. So we've got two options here. Well, here's our bug report. Okay, when it crashes, don't bother submitting it. They don't listen, they don't care. But Chitubox, I have it set to save every minute, so it's possible that it auto-saved a version later than what I had, but honestly probably not. But let's just see what it saved. Let's see. I may have to load the one I saved if it wasn't. No, looks like it saved right about the point where I saved. Okay, well, we're good. Oh, no, it didn't. I'm sorry, I'm looking at, oh yeah, no, it did. It did, okay. So, like I say, either recover from the autosave, see if it's a later version than what you had manually saved. In this case, the autosave was more recent, so I don't have to completely redo this edge. Just, I'm only redoing most of it. Or wait, had I already done this edge? Whatever, I'm all confused. I'm sorry, yeah, no, the one I saved was actually newer. All right. Okay, we successfully did all the edges. Let's go ahead and save it again. And by the way, if you are experienced with 3D printing, you might be thinking to yourself, why in the world is he adding so many supports? I mean, you know, a lot of times when you see people add supports, it's nowhere near this density and they use the heavier supports. Well, the reason is with this particular geometry, with basically a rectangle with flat edges, you need all these supports to hold it into perfect position. Trust me on this. It will fail if you don't have this density of supports. Okay, so we did the edges, but now we have to do kind of the inside because the auto support did not do enough. You need to have on this red area, which means that it is not supported. I mean, that's basically what the red tells you, right? That it's aimed down, it's at a bad angle. You need to go in here and just start adding more. The orange areas too, the yellow not so much, but anywhere that there is red, especially dark red, you need to just add more supports. Yeah, that's iffy in there, but it might work. If you don't do this, when it prints, it's going to either sag and give you a bad result, or it can fail. Matter of fact, failing is probably the most likely outcome if you do not add additional supports to the red areas in here. Okay, and also this is another case of, so actually right here is a weird one. It's like, do I really need supports? I don't know, maybe. Doesn't hurt. Save and save often. So here, I just did that much. Let me save, because it will crash here too. Well, we crashed again. Okay, that's the second time. No problem. Let's just load this up. And this time, we're not going to restore from the latest version. And this time, let me just drag the version I was working on, or the version that I'd saved over. And we'll just continue from there. How far? All right, well, it lost a fair amount of work. Crud, geez. This is the problem. I don't know if this crashing has been fixed in the new version of Chitubox, the one that nobody likes. It might still crash for all I know. So, you know, all right, and that should be all of it. Then I just kind of take a quick look, make sure there wasn't anything obvious I missed. This could probably use a little more. There's one probably missing right here. Just do a little quick scan, make sure there's no big gaps in supports. Okay, that's basically it for that. We're going to save it. It should not crash anymore at this point. All right. I'm going to go back over here, and basically at this point it's really just you set this up however you want. So I'm currently using the Elegoo ABS-like resin. I've been using their standard resin for a really long time, years, and really in the last, I don't know, year or so I switched to the ABS-like, and the reason was I found that it didn't warp as much when it cured. The problem with the standard resin, well, all the resins, is that when they cure, they shrink a little bit, and it can warp the model if it's too thin. It wasn't a huge problem, but sometimes the corners would just lift up just a fraction of a millimeter. It didn't really affect the top at all. But anyway, the ABS I found works better. So what I want to show you is, slice settings, sorry. The settings that I'm using. This is going to vary depending on your printer and your resin. But these are my settings for my Elegoo Saturn with the Elegoo ABS-like resin. I'm always using the 0.5 layer height, by the way. Exposure time 2.4 seconds. Do a really long bottom exposure with this stuff. And then, also in the resin, we can kind of do this down. Actually, this is what I really want to show you. Like I said, the resin shrinks. And most of the time, if you don't account for that, it's no big deal, right? Your mineral is still going to fit perfectly in there. But there are cases, especially like with this particular one, because it's got a very complex impression. You want to make sure you want to give it a little bit of wiggle room and make sure that they're extra precise. So I have turned on the shrinkage compensation and the tolerance compensation options in advanced. And what this does is, so I printed out some known size things, measured them with my calipers, and found that on the x-axis it was off by 0.8%, x and y. And then on the z it's barely off at all. Okay, it was almost exact. But I go ahead and I added this in to compensate. So when the resin shrinks after curing, it should be the right size. Same with the tolerance, well, not same, but what the tolerance does is on the inside of the impression, I'm just giving it a teeny bit of extra wiggle room. I'm basically loosening up the mold, just a teeny bit, just in case, just so things aren't too tight. And those are really the settings that I use. And then from here, I just go ahead, slice it, and then do island detection. By the way, this is super important. I think a lot of people don't even understand how this works. You have to do this because there are going to be bits in here that are not supported, that are hanging down. And if the 3D printer tries printing them, it's going to result either in stuff stuck to your FEP, or they're just going to be floating around freely. And we don't want that. So start detect. This can take a little while. It's basically scanning your entire thing, looking for islands in the geometry, and it will find them. I'm going to guess, I'm going to go ahead and say it finds, I don't know, 8. I'm going to say it finds 8 in this one. Oh, I was way off. It found 20 of them. Okay, all we got to do is delete islands. Okay, that'll delete the ones it found, and then I do it again. Okay, do another detect islands. And this time it found 6, so let's delete them again. Now I usually only do 3 passes of this. This can go on forever, but let's just do one more. And it still has 4, but you know what? I'm going to delete those. Every time you do it, there'll be less and less. There might still be one little microscopic one left. There usually is. I mean, sometimes it's impossible to get all of them. You'll be here all day doing this. I'm happy with where it is now. There's either going to be 0 or maybe 1 left at this point, but it's going to be literally a microspec. It got all the big ones. Okay, so that's basically it. At this point, I'm either going to save it to the SD card or the thumb drive and send it over to the printer, or I'll just do the network sending and print it out. And that's where we go to the next step of this process. All right, so at this point, I'm going to assume that you know how to use your 3D printer. I'm just going to take that for granted. I'm going to take for granted you were able to send the model to the printer and it's printed and it's done. And I know that you probably understand how to clean it with the IPA, but I'm just going to kind of go over some little details about what I do. And we're also going to have to suspend our disbelief here because I don't actually have anything in my printer right now to show you, so pretend like there is. But this is what I do. This is my process. When something is done printing in here, I go ahead, remove the build plate, and I will drip it. And I'll drip it using this little it's a drip adapter that I got, it's a 3D model I downloaded and printed out, and just allows me to mount this thing sideways so that all the resin drips off. And I'll usually let it drip for about an hour, if not more, to get all of that resin off. That way I'm not wasting any resin. And then I go through a 3-step resin bath. This tub right here is the dirty one. So I will submerge the entire build plate in here just to get the really goopy stuff off. And then once that's off, then I'll remove the model from the build plate, remove the supports, and then I'll throw it into the cleaner machine. And I usually run it in there for, usually about 11 minutes, something in that range, plus or minus, depending on how big of a model it is or how many models I'm doing at the same time. And by the way, because the Saturn is so big, I find it very efficient to print multiple bases at a time. This whole process is very inefficient if you're just printing one base. So I try to do multiples. I try to print anywhere from 3 to 5 bases in the Saturn at the same time, because it's a pretty good sized build plate, and that's usually about what I can fit in there. And the same for over here. I throw all of the bases that were on the build plate in here. I wash them. Then when they're out, then back here, there's a clean bath of IPA, and I'll do like a final rinse just to make sure that there's no extra film on there. And then at that point, I just kind of put it over here, prop them up on the edge of this silicone tray, and just let them dry. I'll have this fan going full blast. Well, I'll have it going full blast during this because the IPA fumes and the resin fumes are just horrible. So this will be on full blast. Put it down there, I'll lower the fan and just let it sit here for an hour or 2 or longer sometimes to let it completely dry. Okay, and then once the objects are dry, then I just take them over here to the curing station, throw them in there for about 3.5 minutes, and then they should be completely cured and done. However, at the end of that, the bases are definitely not finished because they come out looking like 3D printed plastic bases. They don't have a matte finish. They just don't look museum quality yet. They look like 3D printed objects, and you can usually even still see some of the layer lines. Now on a resin printer, the layer lines are very, very fine, so it's not anywhere near as bad as an FDM printer, but still they're going to be there. So the next step is where it really starts to come together. The next step to getting these things to look really good is airbrushing them. And the way I do this is, well, I've created a whole bunch of these little stands. These are actually homemade. I made them out of leftover packing material from my Elegoo Saturn and Mars printers. It comes with really nice packing foam in those things. And then these wires are actually just hanger wire that I cut up and then hot glued in here. And over the years, they've gotten covered pretty heavily with the paint. But anyway, what I'll do is I'll take all the bases that are ready to go and just kind of put them on here so that they're really easy to airbrush. And then stack them up, get them all prepped and ready, and then when I'm ready to go, I will turn this thing on. And it's about to get a little loud, but you can kind of see in there. I'm going to turn it off so you can hear me better, but at this point, we're going to be airbrushing these guys. And I'm not going to show you the actual process because I don't actually have anything ready to go, and it really doesn't matter. What is important here is what I'm using and the number of steps involved. So the first thing you're going to want to get is a bottle of this. It's called 3D Prime. It's a primer that helps fill in some of the layer lines on the 3D print. And I've fiddled with different versions of this thing, so they do make this in different colors. I kind of prefer the clear one or the white one. The clear and the white are both the same color in the bottle. Oh, this is the translucent one right here. And the reason that you don't want to get the black version is that it's really hard to tell when you're painting the next layer on if you've covered this, right? So by using the translucent one, when I airbrush the model with this, and I do about 3 coats on here. So I'll do 1 coat, go to the next model, and then when I'm done, come back, do a 3rd coat. Basically just cycle through all the ones that are ready to go. I try to do like 5 to 7 or more at a time. It's the most efficient way to do it. But put about 3 coats, and after those 3 coats, those layer lines are going to pretty much disappear. This will have filled them in. And it'll make the base, it'll give it kind of a frosty black color, right? So you'll be able to see where you missed and where you got it. And that, like I say, that'll be on here, in there, do that. Then, while those are kind of drying, I need to do a rinse of the airbrush, kind of get all that primer out of there and just dry it off a bit. It takes a couple of minutes. And then I will go ahead and load it up with this, it's called Stynel Res. It's made by Badger, but this is also technically a primer, but it's the black. It's the flat or matte black, whatever they call it, flat. It's the serial number, the model number is SNR163. That's the one that you want to get. And this stuff is great. This is what I've been using for 5.5 years. And you're going to load the airbrush up with this stuff, and the exact same process. You're going to want to do roughly 3 coats on every single base. So in the end, you're going to end up with 6 coats. 3 coats of the 3D Prime and 3 coats of the black stuff on here. And then you just have to let it dry. And then once it's dry, the final step. And the final step here is to put the ink on the text and also put the little feet on the bottom of the base. A few things about this. So for starters, I have only been able to find one thing that works, and it's this brand, this StazOn brand of stamp ink. And let me try to open it here. So most ink pads that you buy are going to be water-based, and they just don't stick to this. They're meant for stamping things on paper, right? This is an oil-based stamp pad. It will stick to anything, and including your fingers. You got to be real careful about that. And so what I do And by the way, they do make this in different colors. I've got several colors: gold, silver, copper, white, and so on. 99% of our bases are always done in this silver color. It's just what looks best on here. White is a little too contrasty, so I don't like to do it, but sometimes customers want it. And the gold and the copper kind of look cheesy, to be perfectly honest, so we hardly ever do those colors. Whoa, my God, I sent it flying. All right. In order to get the ink on here, you've got to mask this off. You can't just stamp it or stamp it. You'll get ink all over this thing. And as you can see, I've got a whole lot of tape on the table here. This is just, I reuse this stuff. And what I do is I just really just put it down around the letters. I cover the whole front face of this thing with this tape. It's just regular old painter's tape. I think it's the 1-inch version, that you get over at Home Depot or Lowe's. And, just start like that. Just, oops, there's a little extra piece there. And just mask off as much as you can. And then when you're done masking it, like I say, again, there's economy of scale here. I will do all the bases, mask all of them all at the same time. So I might have a table full of these things. And then when it's all masked, it's not masked yet, I didn't do the whole thing, I will make sure that there's enough ink on the pad, and I will just press it in and maybe stick it down there a couple of times until it looks like it has good coverage. And then once it's on there, or once you've stamped all of them that you have on the table waiting, you want to remove the tape immediately. Okay, you want to remove the tape while the ink's still a little bit wet, otherwise some things can happen. And I will just remove the tape, making sure to not get any wet ink splattered on the base. That happens every now and then, by the way. Every now and then I'll either get some on my fingers and I'll accidentally touch the base, or some of it just gets on there. Usually it's a teeny little speck, and it's very easy to fix. I'll just take a tiny paintbrush, put some of that black ink, and just put a dot on it. And once that dot dries, you can hardly tell that you patched it up. So that's what I will do. Once the ink is on there, we will end up with a base that looks like this with text. And then to add the little, as you can see, this one already has the little felt pads on it. I used to be able to get rolls of 1,000 of these things from a company, and these are 1/4-inch felt dots, black ones. It is impossible to get these in 1/4-inch anymore. The company that made these went out of business, and you literally cannot. I have scrounged the universe. I found one person on Etsy that had a stack of, I think, 500 of them left, and I bought every one that they had. I had to pay a fortune for them. Those were cheap. This cost me a lot of money because they were the last ones in existence. I can't even get them on AliExpress. That's how hard they are to find. So you may have to figure out another alternative. You may have to cut these yourself or use a hole punch or something to make your own 1/4-inch felt pads, because you don't want to use the larger ones. They just don't look good. They don't fit very well, especially on smaller bases. But these are super sticky, and I just stick them into the corners and they work. Now, on larger bases, when you start getting up to a certain size, you don't know necessarily, if you're doing this for a customer, what they're putting on here, how heavy it's going to be. And I found, I learned from experience, that there are some customers that would put really heavy things on here, and it would cause the base, even thick ones, to bend just a little bit. I mean, just enough that you can go, that looks not quite right. So what I do is, in addition to the 4 corners, I will put additional pads, towards the middle, around the, make a center spot so that when it lays, it has support, and that way it will not flex when there's weight put on it. And that's it. Once the ink is dried, which generally takes 20-30 minutes, you're good to go. However, I do recommend waiting overnight for everything to completely dry. The matte black ink takes, I usually let it dry for an hour and a half, roughly, maybe a little bit longer before I start touching it. But even then, it's not fully cured. So I find it's best to, I have a little flat over here. As I finish these, I throw them into the flat, let them sit overnight. I don't ship these to customers right away. I don't put my minerals on them right away. I just wait until it is fully cured overnight so that nothing sticks. And that's basically it. So that is our entire process for making these 3D bases. I know this was an extraordinarily long video. There's a lot in there, and if you made it through, congratulations. If you have any questions about this whole process, feel free to email me. I'm happy to help out. If anything didn't make sense, just let me know. And that's it. So happy 3D printing.